Greetings, M Squared here, and today we're going to solve linear equations with variables on both sides. So there's three things that can happen when you have variables on both sides. And this only can happen if you have variables on both sides. If you have variables on one side, then you always get a solution. But when you have variables on both sides, sometimes the variables can cancel out. So if they don't cancel out, you're left with just an x equals 3. And those are the equations we've been working on. But if they have variables on both sides, there's a possibility. So do you see how this is a 3x and that when I combine those guys, that's also a 3x? So if I subtract 3x from both sides, I'm going to get 7 equals 5. Now 7 does not equal 5, never. So that's a false statement. When variables cancel out and we get a false statement, what we're saying is that there's no value of x which would make that true. Because when we're solving an equation, that's what we're asked to find, the value of x that would make an equation true. But sometimes there's no value that makes it true. So that's how you get a no solution. How you get an infinitely many solution is when the variables cancel out, but you're left with a true statement. So if I distributed this, I would get the same exact thing on both sides. And that's the hint. When you get the same thing on both sides, if I subtract 3x from both sides, they're going to cancel out. And I'm left with negative 12 equals negative 12, which is true. Negative 12 does equal negative 12. So if you're left with a true statement, then you have an infinitely many solution. That means you could plug any number you wanted in there and it would be true. So if I plug 0 in, 0 minus 4 times 3 is negative 4 times 3 is negative 12. 3 times 0 is 0 minus 12. Any number you want. Plug it in for every x you see and you'll get a true statement. So with that in mind, let's solve some equations, keeping in mind that that's probably what's going to happen. We're going to get one of three things, either one solution, no solution, or an infinitely many solutions. So there's different ways you can look at this. Some people look at it and they don't recognize that the variables are the same. Do you see how there's a 2/3 m on both sides? If you can see that you have the same amount of variables on both sides and you cancel those out and the statement that's left is false, I already know this is a no solution. But for those who just focus on the fraction and not the big picture, let's show you how to do it. What you would do to get rid of the denominator is to find out what the common denominator is. Now the nice thing here is they're all 3. That means we just have to multiply the entire equation by 3. Well, that means I have to distribute. So that means I'm multiplying this fraction by 3, this fraction by 3. Each term is getting multiplied by 3. When I do that, remember I just distributed that, so that's not there anymore. This 3 cancels out. Those 3's all cancel out because 3 divided by 3 is 1. Now, if you didn't cancel it out and you said 1 times 3 divided by 3, you'd get a 1. So you could do it the other way if you don't like to cancel it out. But it's easier to remember that 3 divided by 3 is 1 and then times by 2. Because division and multiplication have the same priority, so we can do it either way when that's all that's there. So I'm left with a 2m minus 2. So now you'll see that when I go to subtract 2m from both sides to get rid of I'm trying to get my variables on one side, but they actually cancel out, so I get a big 0 on both of those. I'm left with 1 equals negative 2. Because that's a false statement, I know that I have no solution. So when you're working with this type of problem, it's really a good idea to look at the problem first with a big picture in mind, not worrying about the fractions or parentheses or decimals, but just seeing, hey, are the variables going to cancel out? Sometimes it's easy to see, sometimes it's not. So just watch out for that. Okay, our next problem is right here, and we are going to look at that. Now, I am going to either distribute that or get rid of this 1/3 by multiplying by 3. So, first thing I'm going to do, because I like to get rid of this first, I'm going to add 10 to both sides. So, when I do that, this cancels out, and I'm left with this. Negative 3x plus 12. Now I can either distribute or I could multiply both sides by 3, but I find that it's probably better for most kids to distribute. It's okay if you want to just multiply both sides by 3. You'd have to multiply each of those by 3. So 1/3 times x is 1/3 x. 1/3 times 6 is 2. Now up here I could tell that the variables weren't going to cancel out. See the 1/3 x and the 3x. So I know I'm going to have a solution to this. Here we go. And so now I'm going to subtract 2 from both sides because I want to get that 1/3 x by itself, so it's easier for me to get rid of that 1/3, because sometimes I find people make a mistake if they don't get the fraction by itself first, if there's only one fraction. So now I'm going to multiply everything by 3. So I'm going to distribute that 3 again. So this is going to be x, because 1/3 of 3 is 1, and negative 9x and 30. And I'm going to add 9x to both sides, and I'm going to get 10x equals 30. And then when I divide by 10, I'm going to get x equals 3. And I can check it real quick. It's always good to check it. What's 3? So I'm going to put the 3 back in here. What's 3 plus 6? 9. 9 divided by 3? 3 minus 10, that's a negative 7. Now I'm going to put it on this side and see if I get the same thing. So negative 3 times 3 is negative 9, plus 2 is also negative 7. So I know I'm right. It's always good to check to see if you're right. Okay, last example for today. You see the decimals. So if you're not familiar with decimals and you don't like it, then get your calculator up. You know, if you can think of, I think of it as 25 times 2 is 50, so then I ignored the decimal, so it's going to be 5. But you could always use your calculator if your teacher lets you. So, and it'll tell you right there. So we get 5z, I'm distributing, plus, and then 2.5. If you have this kind of calculator, you could always arrow back, and then it's really nice, because 25 times 5 is 125, but we have to put that decimal back because of what we did. We kind of ignored it to get it right. And I put a little line through my z's so you don't think it's a 2. So that's what I'm doing with my z's there. Okay, we already did 5 times 2.5 over there, so we should know that it's 12.5. Always pay attention to what you were doing before, and then you can save time. Whoops. So what do you notice here? I notice that the variables are going to cancel out, right, when I subtract 5z from both sides. And then I notice that I get 12.5 equals 12.5, and that's a true statement. So that means I have infinitely many solutions. And I'm going to use that symbol for infinity so I don't have to write that word out. So that's what it looks like when you have infinitely many. Both sides look exactly the same. So remember, look at the big picture and watch for details. M squared, signing out.